and its critical role in supporting modern cloud computing infrastructure. As cloud-based architecture continues to grow exponentially, the underlying data center networks face increasing challenges in maintaining performance, reliability, and scalability. Modern cloud applications typically use a microservices architecture where there are separate servers which need to communicate with each other. For example, a single page load at Facebook consists of over 130 different data requests between the different services. This creates complex networking requirements, including high bandwidth demands, low latency, and reliable communication between services. Network security is also of utmost importance, as customers often require features like virtual private networks and private subnets to isolate their components from the internet, and fixed public IP addresses to communicate with external services for security reasons. The figure here shows a rough network architecture where databases and servers are in a private subnet, which is isolated from the public internet. Egress traffic passes through the net gateway, which assigns a static egress IP address. Data centers face three major challenges when supporting cloud applications. First, they must have sufficient bandwidth to handle enormous data volumes from transactions and analytics. Second, they need to support various data formats and protocols used by different services like JSON and images. Finally, they must cope with high velocity data processing, especially during peak periods where there are millions of requests that need to be processed per second. Data centers employ three main network architectures. The first is the hierarchical model, like the three-tier architecture, which is shown in the diagram. In the three-tier architecture, core switches connect to the internet and manage external traffic and interact with the aggregation layer, which then distributes traffic to the edge layer, which connects directly to the physical servers. While this topology is simple, when connecting thousands of servers, it can create bottlenecks, particularly during heavy traffic periods, like e-commerce during Black Friday sales. Recursive models like B-Cube offer better scalability but require more complex routing. Rack-to-rack models like Jellyfish provide efficient connectivity by building a random graph to build end-to-end communication. Of these three models, hierarchical models are the most commonly used and are battle tested. Virtualization is the backbone of modern data centers. Server virtualization allows multiple isolated virtual machines to operate on the same hardware, allowing for isolation of resource allocation and network communication. Data centers use virtual links to connect between different virtual machines and switches, and these ensure that network traffic from one customer can never mix with or be seen by another customer system, which is important for networking security. Network function virtualization allows traditional network hardware functions to act as software, and it enables cloud providers to offer virtual private clouds, custom subnets, and configurable firewalls, all the networking features that modern large-scale applications depend on. Software-defined networking is the backbone of NFV, and it uses a centralized control plane to control networking rules of low-level components like switches. In traditional networking, each networking device controls its own networking rules, making them hard to configure dynamically. By centralizing control over networking rules in the control plane, SDN helps changes in customers' networking configurations to rapidly propagate to all relevant components in the data center. Besides virtualization, another important networking protocol is the network time protocol. Accurate time is very important for distributed databases in data centers to agree on the order of transactions. Besides NTP, network address translation is also used in data centers. Net gateways, which are built on top of network virtualization technologies, help to provide customers with other cloud computing features like fixed egress public IP addresses. Looking ahead, artificial intelligence will play a crucial role in optimizing resource allocation, which can help data centers to reduce wastage and costs. We expect to see more cost-effective SDN implementations through the use of commodity switches, which are a lot cheaper than the specialized switches that are currently required. Additionally, as newer network topologies mature, we may see greater adoption of promising architectures like the rack-to-rack models.